Okay, so we're going to solve for x. The cube root of 7x is equal to the square root of x. I feel like trying this with guess and check would be pretty annoying. There is a cool way to solve it. So let's copy it down. Let's put some parentheses around both sides. We're going to exponentiate both sides to the power of 6. And you'll see in a second why we're doing that. So I'm going to copy this stuff down, copy down this 7x, and we can rewrite the cube root as a 1/3 exponent. And same thing on this side, we can rewrite the square root as a 1/2 exponent. If you ever have a fraction as an exponent, the denominator is the index of the root. So when we do exponent to the power of an exponent, we multiply these exponents. So 1/3 times 6 is 2, and 1/2 times 6 is 3. So this 2 gets distributed to both the 7 and to the x squared. And yes, it does get distributed. You can say distribution when you're talking about exponents. And then on this side, it's just going to be x cubed. Let's change the 7 squared into 49, and then let's subtract 49x squared from both sides. Left-hand side is 0, and the right-hand side is x cubed minus 49x squared. Let's copy down the 0. And on the right-hand side, both of these terms have a common factor of x squared, so we're going to factor that out. So x squared times what gives us x cubed? That's x. And x squared times what gives us negative 49x squared? That is negative 49. If we want to check ourselves, we can redistribute this back here. So now from here, if either one of these is equal to 0, this will be a true statement. So the value of x that makes this 0 is 0, and the value of x that makes this 0 is 49. So these are two possible solutions. In order to check them, let's get rid of all this work and bring them up here. And we're going to take our equation, plug in 0 for the x's, and plug in 49 for the x's. Both our solutions work, so let's put each of them in a box. How exciting.